We've got the complete game logic, but we're losing money on every play, so today we'll build the coinage and credit circuits. We went over this logic extensively in part 14, so I won't redo that here. Both sections need hardware, so let's get all that out of the way first. On the coinage side, we have the coin switch debouncers. We'll use 4 240 inverters and run those through level shifters to 2 input ports. When we were doing the operational latch, I lied when I said we ran out of LVC 244 gates. I was reserving the last 2 for these. Now we really are out of level shifters, but we still have this extra coin push button we added to the retro circuit board. Luckily for us, this whole circuit in port already exists as our debug button number 2. We'll simply repurpose it for the coin push button. We also need another port for the coin counter output. We've tested the 2N5190 driver before and will add a dual site for these on the circuit board, but I'm just going to use a small switching transistor and an LED on the breadboard. You'll notice we're using an inverter here. Same rule applies where the ICE 40 port initializes high. Using the inverter keeps that driver transistor off by default so we don't end up adding fake coin drops during power on and startup. The port we need is already in use by test button 1, so we'll retire him as well. Over on the credit side, we drive the 2 start game lamps. You need 1 or more credits to start a 1-player game and 2 or more to start a 2-player game. We'll run those through a pair of 74LS244 gates, then transistor drivers. I'll use cheap switchers, but we will add dual sites to support SCRs on the circuit board. Alright, you know the drill. We need to add these to the PCF file. Remove those test buttons. Add the ports to main. Also clear those. To test the ports and hardware, we can temporarily route the coin push button to the coin counter, and we can route the coin switch inputs to the credit lamp outputs. Try the coin button, the coin counter LED lights. Try the coin switches. They drive the respective credit LEDs. Good. All of our new ports and hardware work. Get rid of that test stuff. Now create a new file for the coinage section. For inputs, we have our 2 coin switch feeds, plus the extra coin push button line, 64 Victor, 16 Victor Prime, and 4 Victor Prime. She then puts out credit. They labeled it coin, but credit makes more sense here because we sometimes put out 2 pulses for 1 coin. The 2 CSW lines also drive the coin counter, so we can merge them here and emit the single line that will drive the output port directly. The 2 coin number signals set the operational latch. On the original and retro, there are 2 diodes feeding the set side of the latch. To save pins, we only drive 1 diode, so we need to merge them here and can directly drive the port from this module. Add those parameters. We also need a configuration parameter to replace S3. Let's wire this up, starting with the top coin path. Add the first stage set type latch. Add the second stage set type latch. Add the third stage plain latch. Add the SR latch. And finally generate the top credit line. Do the bottom path. Not going to copy this time, too complex. Add the second stage set type latch. Add the third stage plain latch. Add the SR latch. And finally generate the bottom credit line. We can now assign the credit output, then drive the coin counter output, and finally assign the Q set output. I forgot that underscore. Copy the signature and drop into main. Configure 1 credit per coin for now. We only need a loose wire for credit. Both the coin counter and Q set outputs drive main ports directly. But we will have to remove that temporary assignment. We don't have the credit section yet, so we'll still need to temporarily assign values to those signals so the compiler doesn't bitch. We can test the credit output by adding a test counter and displaying the output on the debug hex display. Try that out. The Q latch gets set and the coin counter driver LED flashes, but no credits accumulate. Everything's wired correctly, but what I discovered is that our SR latch is only an approximation of the 74279 latches. There is a large variety of set-reset scenarios that are handled differently on the discrete part as compared to our registered approach in the FPGA. The issue here is that this logic prefers that the set line take priority over the reset line when both are asserted at the same time. You can see that the 279 datasheet also shows set priority. I'll reverse the always block check order in our SR latch so that the coinage logic works. We'll have to see if we break anything else. Great, we're bumping that credit line. Oh, we forgot to incorporate that extra coin push button signal. On the retro, we discovered we can simply hook the button to the reset side of coin 2's second latch stage. On the discrete 7474, we found out that pulling down the reset while the set was also held down causes both outputs to turn on. In our FPGA part, this is not allowed. I'm going to go cheap here, remove the parameter, and simply merge the push button signal with CSW2. Try that out. The push button sets the operational latch and adds credits. Perfect. The credit line feeds the credit section, so let's build that next. I'll start a new file and add the credit module. For inputs, we'll need that credit line, bonus credit, which will come from the bonus logic, 1 credit start, 2 credit start, 8 Victor, and Q. She then puts out the 1+ credits and 2+ credits lines. We'll also expose the credit counter so we can show it on our debug display. And it looks like we're going to have lots of fun with this one. Let's wire it up. Do the 193. And the outputs. Pretty simple. Copy that signature to main and connect it up. The 2 credit lamp lines will drive the output ports directly, but we will need a bus for the counter. We do need to remove those temporary assignments. Oh, those start game signals are active low. Fix that. and remove the temporary test stuff. Build that. Wow, she puked hard. We'll need to add two 1/2 clock loop buster delays to the carry and borrow outputs. Now use the delayed lines on the inputs. And we need to add clock to the parameters. The build is clean, so let's test that out. A single coin drop increments the credit counter and turns on the one-player game start lamp. Another drop increments again and turns on the start two-player game lamp. Start a one-player game and the counter drops by 1. Reset that, add 1 credit. Try to start a two-player game and nothing, shouldn't be able to. Add another credit and start a two-player game and still nothing. That's not good. Well, I found the first victim of our SR gate priority reversal. This one prefers that the reset side take priority over the set side. Instead of doing something funky with the gate, let's just reverse the inputs to reverse priority, then simply invert the output when it's used. Try that out again. Add 2 credits. Start a two-player game. Much better. Looks like everything's working. We need to try out that 2 credits per coin logic, so modify that configuration parameter. Now each coin drop adds 2 credits. Last thing we need to do is drive that Q reset output. This doesn't really fit cleanly into any section, so we'll just assign it properly here. This is a safety mechanism that resets the operational latch at the end of a game when there are no more credits. I set the balls per play to 5, and we have no credits left. As soon as we miss the ball, the operational latch is reset. Nice. One thing we should have done on the retro board was to have an option to display the credit counter in the leftmost on-screen display digit instead of the player up number. You already know which player is up because their score is flashing. It's easy to add this feature here, so let's just do it. We just need to add a configuration item for that along with the counter. We can then make a selector for the leftmost on-screen display digit, which is funnel input number 7. Now we can use digit 7 in the funnel inputs, 1 bit for each multiplexer. Convenient that the leftmost digit is on the left in the input list. And that should do it. Just need to add those parameters to the instance. Turn that on, drop some coins, and the credits show up on screen. Very convenient. Last cleanup for today. We will build a configuration module later, but I would like to corral the new configuration parameters with the others. Great! Today we finished the coinage and credit circuits, so we now have a completely working game including the proper accoutrements for making money. Only 2 sections remain from the base product. the bonus logic, and putting up a second wall of bricks. We'll finish those up in the next video, so I'll see you over there.